In this video, we're going to discuss how to divide polynomials using long division. Before we do that, though, let's review what long division looks like with numbers, because if you've seen that before, then long division of polynomials is going to look really similar. So we have the divisor, the dividend is what this is, dividend, and then the divisor. And so for long division, we put the dividend underneath the division sign, and then the divisor on the outside. And then we look at the divisor and the first digit in the number, and sometimes people will say, how many times does 3 go into 3? Or another way to look at it is, what would you multiply the divisor by in order to get that first digit? So we know that 3 times 1 is 3, so we put a 1 up here. And then we multiply that 1 that we just wrote by the divisor. So 1 times 3 is 3, and we write that below here. And then we subtract that off, and we get 0. And then we bring down the 9, and then the whole process starts again. So now we are looking at the divisor and the 9 and saying 3 times what would give us 9? And would be 3 times 3. So we put a 3 up top. And 3 times 3 is 9. And so we subtract that off. We get 0. Bring down the 5. And we can't take 3 times an integer to get 5, so we do the closest we can without going over. So we can't do 3 times 2 because that would be 6. That's too much. So we can do 3 times 1, and that's 3. And then we subtract that from the 5, and we're left with 2. And then we bring down the 1. And now 3 times 7 gives us 21, and I'm out of space here, but then we subtract the 21 from the 21 that was there, and we get 0. And so that 0 is the remainder. And the 1,317 is the quotient. So in other words, if you punch in 3951 divided by 3 in your calculator, it would say 1317. Okay, let's look at this example, and then we're going to highlight a couple of things about the two examples here. So this is going to start out really similar. 3 times 1 gives us 3. Subtract that, bring down the 9. 3 times 3 gives us 9. Subtract that off, bring down the 6. 3 times 2 gives us 6. And then we bring down the 1. Now we can't multiply 3 by an integer to get 1, and remember, we don't want to go over, so we have to do 3 times 0. We need a digit in our ones place there for our quotient. So 0 times 3 is 0, and our remainder is 1. So when you were learning long division with numbers in grade school or something, there's different ways they probably had you write the remainder. One way to interpret this is that the result from the division is 1,320 and 1/3, because that's the remainder over the divisor. So another way to think of that is 1320 plus 1/3, which is how we would write it with the polynomials that we're going to work with eventually. Another relationship we see between the dividend, the divisor, the quotient, and the remainder is this relationship right here. So if the remainder is 0, then the dividend is just the divisor times the quotient, which we saw here. If you take 3 times 1317, that equals 3951 because the remainder was 0. In this case, the dividend is equal to the divisor times the quotient plus the remainder. So if you take 3 times 1320, you get 3960, and then you have to add that remainder of 1 to get the 3961 that we started with. So the reason we bring up this relationship is because when we do this with polynomials, the purpose eventually is going to be to factor the polynomial. And so if we're trying to factor it, remember factoring means we're writing it as a product, so with multiplication. So we won't want to have a remainder when we're factoring. We're going to want to have a remainder of 0. For now, though, when we're just practicing the long division, you may come across problems with a remainder. So let's talk about what this long division process is going to look like with polynomials. We still have a dividend and a divisor, so we're going to set it up just like we did before. And when we did this with numbers, we looked at the first digit in each of the dividend and the divisor. Here we're going to look at the first term since these are polynomials. So we're looking at the x and the x squared there. And just like here, we said 3 times what would give us 3. Now we're saying x times what would give us x squared. And that would be x, right? If we take x times x, that gives us x squared. So we put the x up top, and then just like before, we take what we just wrote and we multiply it by the divisor. Our divisor has 2 terms here, so we want to make sure to take the x at the top times each term in the divisor. So x times x is x squared, and x times 3 is 3x. Okay, now we're going to take that line we just wrote and we're going to subtract it from the dividend, which means we need to subtract every term on the second line from the dividend. So I usually put parentheses around the whole thing and the subtraction out front to remind myself that I'm subtracting both terms. I'm subtracting the x squared and I'm also subtracting the 3x. So in the first column we have x squared minus x squared. That's 0. And that should always be 0 when we're doing this with polynomials. So we get rid of that first term completely. And now we move on to 10x minus 3x, which is 7x. And essentially here you can think of this as a plus 0 term. So we have 21 minus 0 there, which is 21. And now we're going to do the same process again. So we look at x and 7x, and we would need to multiply x by 7 to get 7x. So we put a plus 7 up here. And then we multiply that 7 times both terms in the divisor. Seven times 3 is 21. And then again, we're subtracting both of those terms. So we have 7x minus 7x, which is 0, and 21 minus 21, which is also 0. So that's our remainder there. So essentially what we did is we factored this dividend. We factored that as the divisor, which is x plus 3, times x plus 7, because we got a remainder of 0. So that's something that obviously we would know how to factor without long division. We're going to run into some polynomials, though, that will want to factor that none of our factoring techniques that we've worked so far will work, and so that's when we'll use the long division. Okay, let's do this division. Now notice how we don't have an x squared or an x to the first term there, but we might end up with terms with those powers when we do the multiplication, and then we're going to need a place to subtract them from. So we're going to put in placeholders here. So we're going to put a plus 0x squared and a plus 0x for our placeholders there. And so looking at the first term in each, we would take x times x squared to get that x cubed there. So we put the x squared up top, and then we multiply that times both terms in the divisor. So x squared times x, and x squared times -1. And so this is why we have those placeholders, because now we're going to subtract, and we need to subtract like terms. So x cubed minus x cubed is 0. And then we have 0 minus -1 for our x squared terms. So we have 0 plus 1 essentially there. So we have a positive x squared. And no change in these terms because essentially we're subtracting 0 from them. Okay, now we need x times x to get us that x squared. So put an x up top and then multiply that by the divisor. So x times x times -1. And then we'll subtract that from what we had. So x squared minus x squared is 0. And then again, we have 0 minus -1, which is positive 1. And we have one more step here. X times 1 gives us x. So we're not finished with the long division until the result at the bottom has a degree that's smaller than the degree of the divisor. So at this point, the degrees are equal. They both have x to the first. So we have one more step. So we put a 1 up here. We're going to take 1 times the divisor and write it at the bottom. And then subtract. And we get 0. So we have a remainder of 0 again this time. So once again, we factored that dividend. X cubed minus 1 is equal to the divisor times the quotient. Here's one more example. It's written with the fraction line, but that still indicates division. And our divisor is 3 terms this time. So if any of you prefer to use synthetic division as opposed to long division, you can do that if you want, but you can only do that when the divisor is x plus a number or x minus a number. So in the first two examples, you could use synthetic if you want, because the divisors were both x plus a number or x minus a number. However, in this case, the divisor is not in that format, so synthetic division doesn't work for this one. So we have to use long division here. Okay, so looking at the first term in each, we definitely need a coefficient of 2, and x squared times x squared would give us x to the 4th. So we need a 2x squared here, so that when we multiply it by the x squared there, we get 2x to the 4th. And we're multiplying that 2x squared by every term in the divisor. So we're also going to have 4x cubed minus 6x squared. We subtract every term. So 2 minus 2 is 0, 4 minus 4 is 0, And then negative 5 plus 6 is positive 1. So we have positive x squared there. And so now we have one more step. We can do x squared times 1 to get x squared. And then we need to multiply that 1 times every term in the divisor. And then we subtract. Negative 2 minus negative 3 is negative 2 plus 3, so that's plus 1. Okay, now we're done because the degree down here is 1 and the degree up here is 2. So we can't do any more. So this is our remainder here. And so I'm not sure how they're going to ask you to write it. One thing that we discussed back here, right, we said that in this case where we had a remainder of 1, we wrote the 1 over the divisor and we said it's the same as 1320 and 1/3, or in other words 1320 plus 1/3. So they might ask you to write the answer in that format, the remainder over the divisor as an additional term there. So if that's the case, the answer would look something like this. One thing to notice here is that since we have a remainder, we did not succeed in factoring the dividend because the dividend is equal to the divisor times the quotient plus the remainder. So for ours, that means 2x to the 4th plus 4x cubed minus 5x squared plus 3x minus 2 is equal to the divisor times the quotient plus the remainder. So we didn't factor it because we have this plus sign. When we factor something, we don't see any addition or subtraction outside the parentheses.